Good afternoon, everyone, or good morning, good evening, wherever you're from. Hope you have a very pleasant day so far. And if you're just starting your day, hope it's going to be good. So, today I'd like to sort of take you through some of the common challenges that companies face when it comes to their data handling. So, do they have the right data at the right destination? That's going to be the major theme of today's session. Now it's going to be run basically with by myself and Utkarsh here. Quick introduction of myself. I handle Cribl product in Positka, and I also handle the Japan region as the account manager. And I talk to a lot of companies facing a lot of different problems with their data handling, and I get a first-hand understanding of what these problems are and how we can help assist them overcome these problems. And Utkarsh here is a security consultant and engineer. He has been around for 5+ years here, and he is an expert when it comes to major software such as SIEM, so Cribl. So he'll be giving a quick demo of what we are talking about today at the end of the session. And as for today's agenda, I'll first start off with some of the key challenges faced by security and IT teams in the current day and age, where there's a lot of different data and teams need this data for different reasons at different destinations. So, what are these challenges that come along with these changing factors? So, I'd introduce a couple of them, and then I'll give a quick introduction of Cribl and how it addresses these issues, following which Utkarsh will give a demo on some of the interesting use cases of Cribl. So coming to the key challenges faced by security teams and IT teams, as you all know, like data growth has been tremendous in the past 10, 15 years. Like in 2025 alone, it's expected for 175 zettabytes of data to be generated. And along with increased data, there's also always increased risks, which end up compliance requirements to increase each year. So if you're not retaining data for a specific amount of time in specific regions, like you're going to face penalties that may mount up tremendously. And then with all these variety of data, there's a lot of ways to utilize these data in different solutions. So there's also been a growth in the number of tools being used by organizations for very specific use cases. So when we're talking about tools, let's look at some of the sources, right? Like these are the various data sources that are generating data for teams such as security teams, IT teams to then utilize and get derive value out of. So we have collectors which handle a large amount of data such as Azure Blob, S3, Google Cloud Storage. Then we have push and pull type of data, have TCP, UDP, you have API data, you have agents that generate the data. Like all of these have generate, I mean, these generate different type of data, which provide different unique values if you know what use case you want out of it, or if you know what is the expectation out of these use cases. I mean, these data sources. Now, similarly, there are also a lot of different destinations where all of these data are routed into. And these again come with very specific purposes. Do you need them for cloud storage? Do you need them for business analytics? Do you need them for security monitoring through SIM? Do you need them for just log management? There are different options available for each of these categories. Now, what is driving all of this? Now, security teams, IT teams, each of them require all of these data in different destinations for specific purposes. Now, if you look at security teams, they need all of this data for security visibility. They will need to have this data to ensure that they detect threats on time and then be able to respond on time. They may need this data for forensics. They may need data to be retained for a specific period of time for compliance reasons. Now, similarly, IT teams may have their own reasons for which they need this data. They may need it for operational visibility. They may need for root cause analysis and troubleshooting, for inter-service dependency mapping. So these are just a couple of examples of why certain teams need certain type of data. But the result of this requirement is that large volumes of data are being ingested in multiple tools, and each of them end up with a long retention period, and the data flow itself ends up being very complex, with a variety of different destinations being used for different purposes. And obviously, the number of tools being used by itself has also been drastically increasing the past years. All right.
All right.
So
So
moving
moving
on, let's
let's
see
see.
what is happening in reality. So we have organizations. Let's take an example of a security team, right? We have a security team having a SIM, and they are getting all of these data into their SIM, thinking that all of these are providing value. Because if you look at Windows event logs, it is often ingested into SIM because it is important for tracking user logins and potential lateral movement. Now, likewise, AWS Cloud Trail logs is often considered to be critical for audit trails and detecting misuse of credentials. Likewise, there are all of these data sources generating data, and all of these are logged into SIM. But what is the reality? The expectation here is that, of course, I mean, everyone would love it if all of these provide equal and high quality value, and all of these data is equally important. But the reality is there are basically three types of logs, right? Like one sort of log is where everything in it is useful for a particular use case, which is not as common as you see. The other two types are where you have certain events where parts of the event contain useful information, while the others not so much. They may be verbose metadata, which doesn't really provide all that much value when you're using your SIM for detections and investigation. So, for example, if you look at Windows event logs again, the fields that you might actually need from these logs are more like target username. You have logon type, IP address, and logon process names. But there are some unnecessary fields that also get ingested along with the process. So it all gets ingested in one go, right? And what this leads to is you have more data in your SIM, in your tool of analysis, than what is actually required there. Now, if you look at the other category over here, these are data that don't even have that much security value unless you're completely sophisticated and have thoroughly built out your UVA requirements or your anomaly detections. Unless you have reached that level of sophistication, these particular sources such as application performance monitoring logs, MDM logs, raw logs, these may not have that much security value, and it's just getting ingested, but it's not providing value after the ingestion, right? Now, what this means is that a lot of organizations are getting a lot of data ingested into their various destinations, even though those destinations have very specific purposes that they are built for. And not all of these logs are equally providing value for each of these use cases. The reality is that not too much thought is put into ingestion. Like you just get all of the data in to be on the safer side. That is found to be a common reason for why most organizations tend to just get the logs in and then think about whether to make use cases out of it or not, whether it provides security value or not. So that is the reality of data growth, right? You have a lot of sources sending data to a lot of destinations, and what's happening is all data from all sources are getting sent to all destinations. So there's a huge amount of duplication of data where you don't need all of that data in each of these destinations, right? Each of these destinations have very specific purposes. As long as your data contains only the relevant your parts that are useful in the destination, that is more than sufficient. But this right now is what you see on screen is the reality, where it's just a complete mess. Like data flow is completely messed up, everything's getting sent everywhere, and it's highly inefficient, right? Like not just from a license perspective. Obviously, if you look at the license cost, it's skyrocketing because you're ingesting more data than what you need. It's also affecting the performance. You are forcing your destinations to process more data than what's actually needed to be processed there. So that's taking a toll on your hardware, and there are a lot of complications that arise out of this reality of data flow that you're seeing right now. And obviously the budgets are not keeping up. I think we are all on the same page here when we say that the data is growing exponentially, right? It keeps growing. There's a lot of development each year. It's just going to keep going up. However, the IT budget doesn't grow the same way. It's more linear in uh, it's pretty much it's never going to surpass your data growth, right? So if this is the case, how do you meet your requirements? How do you meet your compliance requirements? How do you maintain your security? How do you make sure that you're addressing your threats and risks with the limited budget despite this data growth? So moving on, what if you we had a lot of discussions, right? Now we raised a lot of problem points and we identified what are some of the key issues being faced by IT teams and security teams right now with increasing data and I mean, not reduce, but pretty much the same level of budget availability, right? But what if you had the choice and flexibility to have just the right data at the right destination when you need it? And what if you can take control and reduce your security risks, reduce your compliance risks by sanitizing data in flight, by masking your data before it reaches the destinations? What if you can standardize your data retention so that you meet your compliance requirements, but at the same time, you're not spending too much on storage when you don't need to store it in the specific destination that you're currently storing it on? And what if you could observe more while spending less on licensing, spending less on hardware and storage, spending less on people, right? So what if you had a single solution sitting between your sources and your destinations, taking in all the data and performing its magic, doing all the transformations you needed to do, and sending only the relevant data to the relevant destinations? So that is what criblstream does. Now, I'll give you a quick introduction of what Cribl as a company is, and we'll move on from there. So Cribbles pretty much define the observability pipeline market. They are known to be vendor agnostic. And what we mean by vendor agnostic is that it doesn't matter what your source is or what your destination is. Cribble has the flexibility to help you take in data from any source and do a lot of transformations, a lot of filtering, reduction in the middle in Cribble itself, and then you push it to a destination where you send only the relevant data to the relevant destination. So this developed by Cribl and its founders bring 30 years of observability experience, strong leadership with experience of leading data security, network, and B2B companies, funded by companies like Sequoia, Tiger Global, Greylock. And so Cribl Stream that I just mentioned is one such solution. It's their signature solution, but they do have a lot of other solutions as well, like Cribl Lake, Cribl Cloud. So for today, we'll focus more on Cribl Stream because that will address a lot of the problems that we were discussing right now. So Cribl's value proposition. Um, So Cribble's value proposition is basically there are a couple of them. I'll go through them one by one. So first up, you have collect. So it is vendor agnostic. So it lets you collect from any source and send it to any observability tool. Then it allows you to enrich the data. So the data is already generated in a lot of different sources, and yes, it may have its own value, but oftentimes if you can add just a bit more of information to that data to enrich it, it will provide a lot more value at your destination in terms of, let's say, like you can add certain fields to your data and make it easily identifiable. You can add certain data to help map it to specific use cases that you may need. So this sort of enrichment is also possible in Cribble before it reaches your destination, before the data reaches your destination. Now, Cribble also helps in reduce, and this is one of its most major selling points, right? Like it helps you control cost by reducing or by removing unnecessary fields or dropping unimportant events. And then you have transform. So you get the data into Cribble Stream and you transform it to the format that is required in your destination. So different destinations may have a different expectation on what the format of the data is when it reaches your destination. So Cribble helps you modify that format before the data reaches your destination. And Cribble also has this unique feature where it helps you mask or encrypt data before it reaches your destination. So there may be cases where you need data in your destination for analysis, but you don't need to see or you don't need everyone to be able to see all data. Like it may contain personally identifiable information such as credit card numbers and all that. You can use Cribl to mask those information before it reaches the destination so that people can still use this data for analysis, but they don't need to have a visibility into more information than what's required for them. So that sort of masking is also possible in Cribl. And next we have routing. So you have same data that you can send to different tools of your choice so that you can pick and choose which data goes where against the same data. So I'll give a quick visualization of this as well in a couple of seconds. But essentially you can route data from any source and you can modify that data and route it to any destination of your choice. Now, replay is again a very interesting use case of Cribl where you are modifying this data, right? You're modifying, you're reducing, you're removing unnecessary fields and dropping unimportant events and sending it to your SIEM. But in terms of your compliance requirements, it's more often than not that you're required to maintain full fidelity data as well. But there's no need for you to maintain this data in your tool of analysis. Tool of analysis can be used for analyzing only, while you can store this full fidelity data in a cheaper long-term storage destination such as S3 or Azure Blob. You can store there and you can use criblstream to route this data back through Cribl into your destination of choice when you need it. So let's say an incident occurred and you need to check your past year's data, but you have only 3 months data in your SIEM. It's not a problem because you would have already sent a full fidelity data into your long-term storage. What you need to do is just quickly use replay and route the data back through Cribl into your destination, which is your SIEM, so that you can perform your forensics, you can perform your investigation without needing this data to sit in SIEM the entire year or something. So that is another major feature of that's another major Cribl's value proposition. So just to visualize it and make it easier to picture, right? When we say routing, let's take one set of data, right? Now you have a couple of different destinations that need this data. What you can do is you can decide which fields go to Splunk, which fields go to, and you can maintain the full fidelity of it. No, full fidelity data in Databricks. So Cribl helps you route this data to different destinations at different levels of information. And then coming to this reduction, so you have data that is coming into Cribl and it contains, so we have highlighted a couple of fields here, right? Like these fields don't really add security value or they are duplicate fields that don't really provide that much value when it reaches the destination. And there's just one example, depending on your source, depending on your specific use case, there's a lot of deduction that you can possibly do in your incoming data, ingested data. So you get this data into Cribl, you apply the filtering pipeline, and you push out the data that's after it's removed the unnecessary fields. So you have a lesser volume of data coming out and into your destination. So this will directly affect your license usage in your destination as well. So just to give a very rough example, if let's say you have 100 GB of data, but you need only 80 GB that's actually of any use, you can send only 80 GB and the remaining 20 you can remove at this stage itself. So you're not sending unnecessary data into your destination and you're not putting unnecessary strain on your resources that are processing this data as well. Now replace what I just explained earlier, where let's say you have a sudden requirement for data that is in S3. You do not have it in your SIEM. An incident occurred, you need it for forensics. No worries at all. You just enable, you use the replay option from criblstream, wherein the data that's already been routed to S3 is easily moved back into your destination of choice. For example, I've used Splunk here and you can access it even though you do not really have this entire data in Splunk the entire time. So that is the value provided by replay function, is that you can meet your retention requirements while not worrying about your license budgets. And lastly, I'd like to give a quick explanation of what I mean when I say data obfuscation, data masking, hashing, or encryption. So Cribl will do transformations before the data reaches the destinations. Now, these transformations can be in the form of what's displayed here, right? You can mask your data, you can hash your data, you can encrypt your data. So what we mean when we say mask is that let's take the CCN example here. In case of masking, you're making it so that not all part of your personally identifiable information is visible to your to the people using your tools of analysis. They'll still need this data for analysis, but they don't need to view the entire number. So in such case, you mask the information. Now, hashing is something a bit unique where once you do it, you cannot reverse it. It's reversible. I mean, it's not reversible, right? So if you hash your CCN, it becomes this, but you can never revert it back to this. However, this number will always result in this hash. Hash is unique that way, right? It maintains the uniqueness of the data. So what this means is that even after hashing your data in Cribl, you can still use it for analytical purposes because it maintains the uniqueness. Now, the third way of data obfuscation possible in Cribl is encryption, where you can encrypt the data and make it unreadable for whoever's viewing it in your destination. However, you can also select or you can configure it so that specific people can use decrypt function at the destination in order to be able to decrypt it back to the CCN. So this is also something that Utkarsh will shortly be demoing as well. But these are various ways in which data obfuscation is possible in Cribl. So before we move on to demo, just to quickly summarize on how Cribl can help you with your data goals, it is going to sit between your sources and your destinations and will help you improve your security. How? By ingesting more high quality data at the same level of license, I mean, at the same license level. So you don't need to increase your license cost, but you can ingest more data because you're reducing unnecessary data and creating more leeway. And you can then meet your compliance requirements. So what this means is that you can store full fidelity data in cheaper long-term storage, and you can replay it back to your destination when you need it. And you can obviously reduce your cost by removing unnecessary fields and unnecessary events before it even reaches the destinations and starts consuming your license. And lastly, you can also improve your performance by reducing the amount of data that's being actually processed at your destination. So these are just a couple of major uh, um, value propositions of Cribl, but there are also a lot of other benefits that it brings to the table. So before, I mean, so that's pretty much a quick rundown of how Cribl can help you maintain your security and help you meet your compliance, reduce your cost, and improve your performance.
Yeah,
Now I'll
Kumlesh,
hand it over.
before we move on,
Yeah.
we have one question in chat.
Okay.
So I think if you would like to answer this now, or we can take it during the Q&A session.
Josh, what do you say?
So let me take that up.
Yeah.
A question is, can we mask obfuscate sensitive information from the logs using Cribl? I think Kumlesh has already answered this, and I will also demo this in the couple of minutes.
All right, then I guess we'll move to the demo and see how Cribl actually looks, how intuitive it is, how easy to use it is, and how you can, some of the use cases that it can enable your team to establish. All right,
Sure.
over to you, Switch.
All right, let's start with the data sources. So Cribl supports majorly three types of collection of data. So we have the collectors, where we collect the data in chunks on a scheduled basis. So, for example, you might have Azure Blob or some database running in your systems, like most of the applications require database these days. Or it might be just an archival, local archival solution, like a file system where you have an NFS and you're pushing all your archival logs over there. So, if you want to collect all of these on a scheduled basis, maybe for incident response purposes, Cribl allows you to collect it from here as well. So this becomes interesting when you have a lot of custom places you want to get the data from. So example, if you want to run a Python, Bash, or even a JavaScript to collect the data. So it gives you all those options to write your own script or maybe just write a REST query to get the data in your system. Next, we have push-based collectors. So this is where Cribl has to go to the sources and collect the data from the source itself. So this is what working on the S2S model for Splunk or API calls, which Cribl has already configured for many data sources. As you can see, we have Splunk TCP, we have Heck input, which is HTTP event collection, and we also have Grafana, Loki, which is quite common these days. Most of the applications will have some graphs and all that stuff to showcase how the performance is working with Prometheus, Grafana, Loki. So most of the common data sources, right, they will be sending data to Cribl in terms of TCP and UDP. So if we look at the most of the major data sources, right, like firewall, so it's pushing the logs in a sense. UDP throws and hopes that the data will reach the destination. So there is no check on it. So this is where Cribl becomes a bit more resilient in terms of keeping the data. So you have a check that it is light enough to make sure the data is stored temporarily in Cribl, and then it picks up and sends it to a destination. In any case, if the data from the destination is, for example, if Splunk is a destination and Splunk goes down, Cribl will make sure the data is still stored in your system in the meantime before sending it over. So it becomes much safer option compared to directly sending it to your destination. Moving on to the last option, we have pull based. So where we have options like Splunk search, where we can write searches in Cribl itself. It can run the search on Splunk and get that exact data. This could also be used to extract reports from Splunk directly and send it to your destination. Or you can also use services like Amazon S3, SQS, where you have some notifications which are queued up. You can ingest them into Cribl as well, and Azure Blob Storage, Event Hub, all the major options are available out of the box over here. Lastly, we want to secure our Cribl as well. So we have a couple of options to get the data from your system itself. You can have your Cribl internal logs or your system logs and use them as well to send it to your security SIEM solution or some storage application. Now moving on to the data destination, which becomes a bit more interesting. So this majorly follows two different types, right? So one is your archival or your storage solution where you want to store majority of your data. Second is your processing solution, which could be like Dynatrace for observability, or your mostly SIEM solution like Splunk, your CrowdStrike, which has launched a new SIEM platform, NGSIM. It could be Google Chronicle, and all those options for processing are also available. Now, as Kumresh already mentioned the PPT, so different processing solution will have different requirements. So you're not limited to sending the same data to all the solution. Observability solution will not require data uh, from your, let's say, what your SIM solution might need, which is security related. Your firewall data might not be required over there. And in the same way, you might not want your performance data to be included in your SIM solution. And for all these solutions, you might have different agents running, different agents collecting from the same system, and they're also clogging up the system at the source side as well. So this is where Cribl is trying to simplify that process. So where we are trying to have any kind of data source, where any agent which you have already deployed, let's say it might be a Splunk agent or it might be a Hotel agent, or if you're on a Fluentd system or Vasu, all that agent can remain there. You don't have to deploy your new agents to get data to different destinations. You can use the same agents, get the data into Cribl, format it, filter it in a manner where the destination, exactly what the destination requires, and exactly in the format that it does, and send it to their destinations. So now moving on to how we connect these. So once you have configured your data sources and destinations, you can have copies of them sent to from one destination to many, or from uh, maybe a half copy of the data to your SIM solution. So let me try to show you how simple that is. So for example, I have configured Palo Alto to send data on a syslog port on the Cribl server. So Palo Alto, as you all know, it's a firewall, so it has a tremendous amount of data. It can go up to terabytes per day. So it might make sense to send it to archival, where we can choose a pass-through option. So in pass-through, we are not performing any kind of filtering, any kind of formatting. We are sending the data as it is. For our archival solution becomes much more relevant because uh, if you are following compliances, making changes to the original data might break that compliance. You might not be able to pass through it because when you want to do in an audit, you might want to show the data in full fidelity as it was to be as a proof that, hey, this activity actually happened without any tampering to the logs. So we have a pass-through option where we can send all the data to a file system archival, or it could be S3 as well. So we can choose our destination and send it over there. Now, we might not want to do that same process for a SIEM solution. So for example, if you want to send it to Splunk, we can choose a pipeline. For example, Palo Alto, we can choose a filtering pipeline and which will only send the relevant data after formatting it to Splunk. And this was as easy as opening this and choosing a pipeline that we have already prepared. Lastly, we also have packs. Packs is nothing but pipelines which is pre-configured for you by the Cribl OEM themselves. So a lot of the common data formats that we have, Palo Alto, Cisco, Checkpoint, Windows, Linux, and you name it, it's a huge list that we have over here. So you can already see pipelines built in that you can just click on and start using. So for example, I already have configured Windows. So if I have any Windows log coming in, be it XML, be it the classic format or the new formats, you can select the pipeline, it will format it for you and send it over to your destination. Now, moving on to how these pipeline actually work. So digging into it a bit more. So I have two use cases set up to show over here. So let's start with Palo Alto filtering. So what are we doing? What is Cribl actually doing to reduce the size of the logs and how much can it actually reduce? So let me run this pipeline. So if you see the raw log, a lot of the feeds, as you also saw in the presentation, are going to be redundant over here. For example, since Palo Alto is also sending in a syslog format, so we have a syslog timestamp followed by the actual timestamp of the log. We also have a couple of tags which are not relevant, and a lot of the data is not security related. It's verbose enough to be used by networking team, but if you want to send it to a SIEM solution like Splunk, many of the fields might not be relevant as they are just zeros or they're empty spaces without commas. Now you will be surprised how much we can save in this particular event just by removing these small things like the extra commas and extra time, date, and all. So let's see how it actually does it. So what we do is we take a event and we break it down into all the fields that we can map it to. So all the timestamp and everything we have filtered it out. Now we can just remove the fields which are not required. For example, cable breaker might not be required. The faculty name, we can remove the fields, which according to our need, maybe for networking person, we feel are not relevant for us. And we can just reassemble them. Once we do that, it will follow the same format. It's still a comma separated. It's still the value names without the key. And if we see how much reduction we got just from doing so, we can see a almost minus 56% reduction in one event. If you do a 56% reduction in one event, and let's say firewall is our 80% of the data, from the 80%, we are getting 56% reduced. That's a huge reduction in the environment. In the number of fields, we removed 9 fields when we had 5 fields when we had 9 in total that were already out. Even a lot of things like the timestamp. So you will see in the official event, the timestamp can be in a format which is not very easy to understand or very easy to parse out, if I have to say, for the SIM solutions. So it's much better that it is already extracted and converted into an epoch format before we send it out to a SIM platform. So it becomes agnostic of the destination. Most of the observability solution, most of the SIM solution prefer the dates to be sent in a epoch format rather than having different formats for each different data type. Now let's move on to the second use case. I want to cover the obfuscation again. So I think Kumresh has given a good explanation on what these three types are. So in Cribl, we can do a masking of the data. So if you already have data which, for example, you have a credit card number, so you might not want the entire credit card number to be uh, removed or to be encrypted or hashed. You might still want to keep a initial part of it or maybe the ending of it depending on what is relevant to categorize that user. The security part of it, which we need to remove, we can completely put an access over there, or we can completely remove the entire the string of it. We can just keep the first six or first 8 digits over here. I would say that's not the preferred way to do it. I would rather say go for encryption and hashing in most of the cases, which gives you a lot more things to play around with. If we go to encryption, as Kumresh mentioned, we can also decrypt it. I will also show that in a couple of minutes. So, for example, we have address and name encrypted. So it's a personally identifiable information. So if it's, let's say it's a banking data, it might not be the best idea to send the username, address of a user into your SIM platform. But at a later stage, when we are in the incident response phase and we have some administrator who wants to look at what the user was, who the user was, who might have done something malicious in a system. At that stage, we might want to give the access to a particular set of users to get the information back into the system. The good thing about encryption is doing it on Cribl specifically is that it encrypts while it stores. So if you're encrypting it on Cribl, it is going to be encrypted when it's stored on your SIM platform or your observability platform. So there's no way to retrieve it back unless a particular user with a particular set of keys is able to or wants to decrypt it. Lastly, we have hashing function, where it's a one-way function where if we have a particular string and we want to retain the uniqueness of the string. If we search for a particular, let's say I have hashed out the account number. Now I want to see how many instances of this account number were present in my log to just calculate how many transactions that particular user might have made. So I can still use a uniqueness of this account number to search through the logs, but I don't particularly get the actual account number to use it for my own means if I have to. Now, if we have encrypted it and hashed it, once we send it to Splunk, so we can see all the data is over here is encrypted. Now, we all still have the unique account numbers. So what we can do is we can take the account number on our choice of SIM platform. We can start filtering out with this. And we can see all the instances where this particular account number was used. And now we are in a situation where we want to decrypt the address and the name of the user because we might be in an incident response phase at this point. So it's as simple as using Cribl decrypt. And the data, we don't have to mention any a particular name of the field to decrypt it. Any information present over here can be decrypted. Now, to set this up is as easy as installing the Cribl app. We set it up and we assign this keys to particular user, and those users in turn will be able to decrypt it. Now, there's one last use case that I want to cover, that is the display of the data. So a lot of security systems, we might have archival solution for our compliance purposes, and we will probably end up in a scenario where we want to ingest the data back into our systems. So this is where we have used Cribl, let's say, to send the data to our archival. It could be local archival or it could be S3. So now from here, once you have set up the source, we can start running the data and see what data we want to take it back into Splunk. We don't have to ingest all of the data. Archive will have terabytes and terabytes of data. So before sending it to the destination, which can ramp up the cost, we want to filter it as much as possible. We are not limited to filtering it just based on the directory structure we might have built. We can filter it to the level of what is the information inside the logs and what do we want from it. So for example, let me pick up this IP address from here and quickly write a use case for it. We can do a raw.include and we can mention, let me paste the new IP address over here and do a preview again. So preview is we are just taking a snapshot of the events that we filtered out. And once we're happy with the query, it can help us build the query to filter exactly to the point the data we need. And once we're happy with this, we can save it as a file or we can send it directly to our destination. All right, so that's it for the demo. Shall we pick up the questions now?
Yeah. Yeah. The chat box.
Okay, we got a question from Jessica. If we filter logs with Cribl to only send secure data to a SIEM, how would our team perform incident response and investigation? Good question, Jessica. So incident response is after incident has happened, and I would assume all your data, you still want to send a full archival of it, a full fidelity of it, sorry, to your archival solution. And as I just showed in the replay option, can narrow it down exactly to the data you want for the investigation. Maybe it's a particular data type that you want to narrow down. Maybe you want the firewall data, or it could be a particular IP that you're looking for in every different kind of data. It could be from your Windows, it could be from your ideas, from firewall. Search for a particular IP and get it into Cribl as soon as possible. So you can build pipelines into Cribl, and getting the data would be as easy as click and shoot. So that will reduce your license cost, make Splunk work just on your security data, which you have alerts and use cases already done. And when in need, quickly get the data back into Splunk and do your research and incident response on it. I hope that answers your question. Also, we have a follow-up over here. Is the data stored in any proprietary format? Cribl does not store the data in a proprietary format. It will store it as a raw data if you want, but more preferably in a gzip or the common compression mechanisms that you have available. If you use compression mechanisms, you can get a reduction of around 8 to 10%, 8 to 10 times on the data. So it becomes easier and cheaper on your archival solution as well. So Cribl does not support any proprietary formats. It's all in open formats. We have one more question from John. We are building a managed service setup where we current customer data with role-based access control in Splunk. Will Cribl be able to do data segregation for us? All right. So MSSP setup, I would assume you have a lot of customers and you want to segregate the data, let's say in Splunk, into different indexes where you can perform a role-based access. So a certain user, SOC analyst, will only be able to perform those research or investigation on set indexes for the customer. It's very much possible. I would say it's a bread and butter of Cribl. So when you have the data coming into Cribl, you can assign tags to it. You can even change the index where it's supposed to go to. So you can take the source, for example, if any data is coming from a particular customer from, let's say he has a firewall coming from a particular host, you can take the host name and you can assign the tags to it and it will go to its relevant index where you can still keep on using your role-based access control. From our past experience, we have seen doing this segregation on the SIEM platform itself can be a bit more daunting and difficult to maintain in long term. If your customer base keeps on growing, what you would have to do on the SIEM platform is mostly a regex-based data segregation, which becomes difficult to maintain in future. In Cribl, you have many more options to segregate data and filter exactly the data you want and tag it to the index you want or the customer you want. I hope that answers your question. Can we map data using lookups? Oh, you absolutely can. You can use lookups. You can have your customer name, and in another column, you can have your source or maybe the host name, and you can just map it every log. You can filter every log to it and map it over there. That's 100% possible. And I would say it's a preferred way of doing things. All right, Vikas, I think that's all the questions we have. Oh, we got one more. Can I search archive data in Cribl? Cribl has a separate product for searching the data, but let's take it this way. So if you want to search the data as in like a SIEM platform, but on your archive data, so Cribl has something called Cribl Search, which is a cloud-based Cribl tool. You can search your data like a SIEM platform directly from your archive. But if the requirement is just to preview the data and filter it before sending it to your SIEM platform where you can actually do your investigation over there, I would say Cribl, on-prem Cribl stream can do it without actually getting the license cost up for you. how difficult it is to set up Cribl in an existing environment. So when you say existing environment, I assume that you already have a lot of agents configured and you still might want to keep those agents. It's going to be a huge process to remove them and deploy new agents just for Cribl to work. So Cribl is agent agnostic. You can use any agents. And for data sources which are not specific to agents, for example, firewall, which is directly sending from the source to your destination, you can have a gradual approach where you can send the data, you can pre-build the pipeline on Cribl. Once you're happy with it, you can quickly just turn the switch, send it to Cribl, and you'll have a full fidelity sent to Archival and your data going to your SIEM or other tools as well.
John
this
has
a-
asked this for one question 2 times.
Oh.
Would you like to address it? Is this a log management solution?
Oh, all right. Is this a log management solution? I would say log management in terms of formatting, filtering the logs, it does manage it. Cribl does not store your logs. It gives you an option to store it in Archival, but that's not the purpose of it. The purpose of it is to narrow down on the logs to exactly what you want and send it to exactly the place you want to. So is it log management? In a way it is, but not as we look at log management in terms of SIEM or observability tool, where we get reports and information out of the logs. I hope that answers it as well.
A copy of this presentation will be shared with all the participants of today's session. And I understand we had only a certain amount of time at the end for Q&A. So if you have any further queries, feel free to reach out to the mail you see on screen on how to set up the data pipeline and how Cribl would be a good fit in your organization. For more information about Cribl itself, you have these links here in this presentation, which will be shared with you later. So you don't need to worry about copying down this link at this point of time.
Yeah.
There's also a free certification. I mean, Cribl provides its own certification and training for how to utilize the platform. It's completely free. You get to learn more on how you can play around with your data and optimize it the way you need it for your organization's requirements. This is the link for Cribl University, and you can also download Cribl for free, and you'll get a license of 1 TB per day, which you can use to then play around and see how you can sort of try and implement some of the things that we discussed today, right? And to enable you do the same, university is there with all of its resources. So these are the resources that are freely available online, and you can give it a try at any time. All right.
Yeah, to add, we will be sharing the recording and also the presentation deck, which we are using right now with everyone for references. So thanks for joining us.
Thank you everyone for joining and have a great rest of the day.
Yep.